Hi folks, today we're going to be looking at factors and multiples. Now you've probably heard of these in primary school. I'm just going to check that you remember them, can do them, and then I'm going to show you some GCSE questions and the range of types of questions they can ask you, just to show you that they can push you quite far with your understanding of factors and multiples with a range of different questions. So even if you're looking at those words thinking, oh, I can do them, bear with me, have a practice. There'll probably be a question in here that challenges you. The biggest problem most people have is they just get them mixed up. So all the way through, be really clear which ones are factors and which one are multiples. Because people generally know what they both are, but they just forget which word applies to which. So be really, really careful that you're thinking carefully about the words in the questions. So we're going to start looking at factors first. And there's a couple of keywords to be aware of. We've got a keyword integer, and that just means a whole number. So 3 is an integer, 6.5 isn't an integer. So integer is an important word. The other one you need to know is the product. Product means multiply. So if you want the product of 3 and 4, you would multiply them. And the product of 3 and 4 is 12. So product just means you want to multiply stuff. Really important words for the next few things we're going to do. Okay, so factors. When a positive integer, a whole number, is written as a product of two whole numbers, the two numbers are called factors of the integer. Okay, now that sounds quite complicated, but it's important that we get used to the language. So when a positive integer, 12, that's a positive integer, is written as a product of two whole numbers, the two numbers are called factors of the integer. 3 and 4 are factors of 12. Okay? So this is a little bit of a table that just helps you understand it. So the definition of a factor is a number by which another value is divisible without a remainder. So it means, and I'll do it with the number 12 again, I can do 12 divided by 3 and I get 4. That means 3 is a factor of 12. I can do 12 divided by 4 and get 3. That means 4 is a factor of 12. If I do 12 divided by 5, well, 2 5s fit into 12, but there would be a remainder of 2. So 5 is not a factor of 12, because when I divide it, there's a remainder. So it has to be divisible without a remainder, and that's just what that means. However, if we look at this box next, often it's a bit easier to think about factors in pairs and to think about them as they are what multiplies to get a whole number. So 1 times 36 is 36. So 1 and 36 are factors of 36. 1 and 36. In this box here, we're listing them. 2 times 18 is 36. So 2 and 18 are factors of 36. 3 multiplied by 12 is 36. So 3 and 12 are factors of 36. 4 multiplied by 9 is 36. So 4 and 9 are factors of 36. And 6 multiplied by 6 is 36. So 6, we only write it once. 6 is a factor of 36. Now notice when we write them in a list. If you write them like this in your exam, you will lose a mark because you're writing multiplications. You're not listing factors. So you mustn't write them like this in an exam. You must list them. And the word list will probably be in the exam question. And that's why, each individual word in the exam question is actually really important. If it says list, write a list. Okay, and that's what I've just said here. Now over here, just remember what isn't a factor. So 10 is not a factor of 36 because 36, when you divide by 10, you would get 3.6. The answer is not an integer. It's not a whole number. Therefore, 10 is not a factor of 36. They have to divide in with no remainder. Okay, very quickly, let's have a think about the factors of 20. So if we're finding the factors of 20, it's worth starting with writing down all the possible ways you can make 20 with factor pairs by multiplying things together. Okay, they're all the ways I can make 20. So I'm going to list those factors. And to be honest, you don't have to, it doesn't matter what order you do them in. You won't get marked down for that. You'll get full marks. So you can just list them like that. And I honestly think it's much easier to list them as the pair, because that way you know that you haven't missed any out. So listing them as a pair is fine. They don't have to be listed in order. And here is an example of how they can sort of use this idea of factors in a different way. So it says determine whether 9 is a factor of 132. So is it a factor of 132? Okay, and then this bit here is telling you, this wouldn't be in the exam question. The exam question would just be the top bit. This bit here is giving you some advice about what to do. So to know whether 9 is a factor of 132, we need to do 132 divided by 9. Now, I can't do that in my head, so I'm going to do it like this. 9 into 42 goes 4 times with a remainder of 6. Now, I would do this if I was actually trying to find the answer. I'm not going to continue because the question is whether it is a factor. So, and I know 9 is not a factor of 132 because it doesn't divide into it exactly. It leaves a remainder, so it is not a factor. To be a factor, it has to divide into it. So this is a way they can ask a slightly different question. So here are some questions to pause and have a go at. Make sure you pause now and have a go at them in your book. The answers are now going to appear. Please make sure you've paused and done these questions before you watched for the answers. Okay, here's some of the answers. I just want to point out that the only ones in question 2 that I had to actually do a calculation for were E and F, and you can see those calculations over here. All the others I could do in my head. It doesn't matter if you couldn't do them in your head, but if you could, that was fine. Just be careful if you got any of them wrong though. Okay, looking at these next two, I'm just going to give you a little bit of a hint. You want to find 3 factors that are also factors of 30. I would recommend that you start by writing out all the factors of 40 and all the factors of 30 in an exam. Because if this was a question in an exam, it's very likely that you would get marks for listing some of those factors. So if you're going to answer a question like this, that's a lot of numbers on there to hold in your head. So I would really recommend that you write them out first and then have a look. So I am looking for factors that are in both lists. That's 1, 2. Oh, I've not done 2 on this one. See, it's really easy to miss stuff out. 2, 5, 10, and I think that's all there is. But remember, it only asked for 3, so any 3 out of those 4 will get you full marks. So for the next one, same idea. Write down all the factors of 48 first. And don't write the factors of 30 out again, because I've got them up here. So write down 4 factors of 48 which are not factors of 30. 1 is 48 isn't, 2 is 24 isn't, 3 is 16 isn't, 4 isn't, 12 isn't, 6 is, 8 isn't. So you only need 4 of those numbers. So there's any 4 of these numbers would get you the marks for that question. Pause the video now and make sure all your work is marked. You should have ticks or corrections on all of your work so far. Now we're going to move on to multiples. And don't forget about these keywords, they're still important. Integer means a whole number. Product means you multiply. Now multiples. When a positive integer, so that's a whole number, is multiplied by a non-zero whole number, so any other whole number, the product, the answer, is called the multiple. So I'll do that again. When a positive integer, 3, is multiplied by another whole number, but you're not allowed 0, 6, the product, that means the answer, is a multiple of these numbers. So 18 is a multiple of 3 and 18 is a multiple of 6. It's almost the opposite to factors. Factors are the bits that make the product. Multiples are what is the product of those numbers. You may have noticed on the last slide, it said, look at this Freya model. This is what a Freya model is. It just gives you lots of different information. So definition, a multiple of any number, a multiple of a number is any number in the multiplication table of that number. And notice both of those words start with multi, because there's lots of them. Multi, if there's multi something, there's lots of them. Multiple things, lots of them. Okay, so we'll go down now. We'll look at example 1. The first 5 multiples of 7 are 7, 14, 21, 28 and 35. They're the first 5 numbers in the 7 times table. So multiples are all about times tables. It's the answers in the times tables. Example 2. 2,450 is a multiple of 10. Because 2,450 is 10 times 45. So because this is the answer when these two numbers are multiplied, then 2,450 is a multiple of 10. We could also say 2,450 is a multiple of 245. It's both those. It's a multiple of both of them. Okay, let's go on to this box next, non-example. 15 is not a multiple of 6 because 15 is not in the 6 times table. Multiples of 6 are all the numbers in the 6 times table. But it's also, and this bit's quite important, also because this division is not a whole number. If 15 was a multiple of 6, it would divide with no remainder. Now you quickly try this, pause the video and decide which one you think, which numbers in that list are multiples of 9. Okay, so you should have 9, 27 and 99. And remember the difference between multiples and factors. 9 would still be a factor, 1 would be a factor, 3 would be a factor. Factors are what goes into 9, what fits into 9. Multiples are what comes out of the 9 times table. So a very quick example, write down the first 6 multiples of 2. That means the first 6 numbers in the 2 times table. Okay, they're the first 6 numbers in the 2 times table. So they are the first 6 multiples of 2. Multiples are just numbers in that times table. And here's where the question gets slightly harder. Determine whether 135 is a multiple of 3. So can I do 3 times something to get 135? Well, I can find out if I divide. If 3 divides into 135, then 135 is a multiple of 3. That's 4 and that's 5. So yes, 135 is a multiple of 3. Here are some questions to have a go at. Pause the video now and have a go. I'm going to show the answers. So if you haven't finished the questions, please pause, make sure you've done them. The answers are going to come up now. Okay, there's the answers. Now, I just want to point something out. That was the only one I needed to do a calculation for, and I just want to look at E. There's something called tests of divisibility. There is a way I can work out whether 3 goes into 108 really simply. You take the number 108 and you add the digits. That comes out as the number 9. Because 9 is divisible by 3, 108 must be divisible by 3. It works with any number in the 3 times table. It also works for the 9 times table, but it doesn't work for any other numbers. So if you want to find out whether something is divisible by 3, think of any random number, 561. 5 add 6 add 1 is 12. 12 is divisible by 3, so 561 is. 245. That's 2 add 4 add 5, which is 11. 11 is not divisible by 3, so 245 is not divisible by 3. It's something worth knowing when you do other things. You can work out whether something is divisible by 3 by adding the digits. If that answer is not divisible by 3, neither is the number you started with. Okay, so here's a GCSE question, and it's circle the number that is not a multiple of 6. So which of these numbers in this list is not a multiple of 6? Pause the video now and have a go. Okay, I'm about to go through the answer. So when I look at this question, I think straight away, well, I know that 24 is a multiple of 6. I don't know the other numbers, they're bigger than sort of the 12 times table, so I don't know off the top of my head whether they are multiples of 6. So I'm going to do the divisions that we practiced before. That one has a remainder, so that is not a multiple of 6. I'm going to double check the other two just because I want to double check that I've not made a mistake. And yep, that is a multiple of 6. It's 6 times 18. And that is a multiple of 6, it's 6 times 24. And that's on a foundation paper, right near the beginning, nice straightforward question. This question asks us to circle the multiple of both 8 and 12. So we want one of these that's a multiple of both 8 and 12. Pause the video now and have a go. So I know that 4 is not a multiple of 8, it's a factor. So 4 is a factor of both 8 and 12. And 4 would be a common incorrect answer because people just get multiples and factors mixed up. As soon as I see that it needs to be a multiple of both, it has to be bigger than 8 or 12. It has to be bigger than 12 or bigger. So I know it's not 4. 32. Now I know that's a multiple of 8, but it is not in the 12 times table. 72. I know that is a multiple of 8 and 12. So yeah. That one is in the 8 times table and it's in the 12 times table. Now, I said it a bit cautiously because I was looking at 108 and I was thinking, oh, hang on, 108 is in the 12 times table. And it threw me a bit that it had an 8 on an end. But now I think about it, 108 is not in the 8 times table. And what you could always do is go to 12 times 8 and add an 8 on and add an 8 on. And then you can see that 108 is not in the 8 times table. But it is 9 times 12, so I know it's in the 12 times table. So I know that the answer is definitely 72. Okay, so here's another example of a GCSE question that has the word multiple in it. Pause the video now and have a go. Let's read the question and go through the answer. If you divide any multiple of 10, my advice would be write down some multiples of 10. As soon as you see something that says like that, multiples of 10, write some of them down. If you divide any of them by 2, the answer always ends in a 5. We'll do it. 10 divided by 2 is 5. 20 divided by 2 is 10. 30 divided by 2 is 15. 40 divided by 2 is 20. So the answer is no. No, it doesn't. Is he correct? Sorry. No. And it says write down a calculation to support your answer. Now, what I haven't done here is shown my calculation. So I take what I've done, which was 20 divided by 2 equals 10. That's a calculation that supports my answer. That is an example of dividing a multiple of 10 by 2 where it doesn't end in a 5. Now we're going to look at some slightly harder ones. Another GCSE question. This one is worth 3 marks. Pause the video now and have a go. Okay, now this question is what we call in context. Instead of just asking you for multiples, a common multiple of 12, 10 and 6, it's giving you a situation where you need that information. So if we want this thing here, the smallest number of boxes, what that's actually asking for is the smallest common multiple of 12, 10 and 6. So they want to buy the same number of diaries, pencils and rulers, the smallest amount. So we're looking for a common multiple. Common means in every list. Common multiple of all 3. Now I've written a few multiples out. Have we got a common one in there now? Yeah. Well, I've got one that's common in 2 but not common in all 3. So I'm just going to keep going a little bit. That one goes up to 60. Or I can get that one to go up to 60. Now I can see here that this one's going up to 60. I will write them out for you, but I would have been able to see 54, not 64. I would know because 30 is in it. I would know that it goes up to 60. So the answer to this question is 60. because 60 is the lowest common multiple of these three things. That's the smallest amount where she could buy the same of each. And this is something called the lowest common multiple. And you can find it, these are quite small numbers, you can find the lowest common multiple of bigger numbers, but that's for another day because it can get quite tricky, that one. Here's another GCSE question. This one's a little bit weird, it just requires you to think about it, but it has got that word multiple in there. Think about what I said on the last question. If you see multiple of 15, what should you do before you try and attempt the question, sorry. Pause the video, have a go. Okay, so this question is actually quite difficult and it just requires a lot of thinking. The first thing I would do, and this might get you some marks even if you don't go on to do much else with the question. The first thing I would do is write down my multiples of 15. I'm going to need to use one of them numbers. So I've got a multiple of 15, and then this second number is 10 times bigger than this third number. Now, what I know is that this number here must be a multiple of 10. It must have a 0 on the end because it's 10 times bigger than this one. So I've got to be really careful now. This number here has to have a 0 on the end, which means these two numbers, because I've got to make 100, they must add up to a multiple of 10. So it gets quite confusing. So if you think, if this was 15, what would I have to add on to make it a multiple of 10? Well, I'd have to add on 5. But if this number's 10 times bigger than this one, that'd make it 50. Well, they don't add up to 100. So if this number was 30, then these two numbers have to add up to a multiple of 10. So that means that would have to be 10, that 100. Well, no, that can't be right. It doesn't make sense. So let's try the number 45. There's a lot of thinking required in this question. So because this number has to add up to a multiple of 10, so must these two, because we're making 100. So that must be a 5. Could be a 15, I suppose, but then that would make the middle one too big. So that must be a 5. If this number here is 10 times bigger, that means that would be 50. Now, do these numbers add up to 100? Yeah. Now, there was a point I had to pause the video and think about this. To get these kind of questions come up, and people really struggle with them because they just take some thinking about. There's no mathematical formula or method that I can give you to get you to answer this question. As long as you know what multiples of 15 are, and as long as you can times by 10, there's just a bit of thinking involved. You've got to try and get used to not giving up. This is the kind of question in an exam. If you weren't sure, you'd probably leave it and come back to it later. Okay. This is the final question we're going to look at. Pause the video and have a look now. Have a go, sorry, now. So this is a bit like the diaries and pencils question, finding a common multiple. So a piano competition takes place every 3 years, a violin competition takes place every 4 years, and both competitions took place in 2009. In which year did the violin competition take place? Right, so we're looking at the violin, that's every 4 years. So we need to go, and I can see all these years are before 2009, so let's go back. Let's go back 4 years, and back 4 years again, and back 4 years again. Is that there? No, back 4 years again. Okay, so it has to be this one. When is the next year after 2009 that both competitions will take place? Well, if they both took place in 2009, the piano is every 3 years. The violin is every 4 years. Now, I haven't quite got a common one yet, but I can see if I go one more year on here, the next year that both competitions will take place is 2024. And I must make sure I write that answer in my answer space. Okay, so they're just an example of some of the questions you could get on factors and multiples. It's really important. The biggest thing you'll probably find is you get mixed up. Remember those words. Factors are the smaller numbers that fit into the other numbers. Multiples are the numbers in those multiplication tables, the times tables. Well done, folks.